Hi, here's a video where I use libpython-clj to explore some Python code in practice using emacs and a Repl. Enjoy it. Clojure. So I have created a project and I use the libpython-clj as clojure JVM dependency, and then I make a Python v environment with Python m venv venv, and I have the script to activate it. This is just something I needed on my setup. I don't think you usually need this. Yeah, so the important thing is source the activate thing. And then I have a script that activates this, sets up the environment, and runs clojure. And this is the one that I use as cider check-in command. So if I evaluate this form, maybe I'll just do it now. So I'm gonna delete my current nRepl, and I'll show this in action. So this starts a clojure REPL, and this is the only time you ever start this. And it takes a little bit longer. These dependencies also take a little bit to load. There you go. Yeah, now you require Python. You call require Python the same way that you call import. There you go. I say torch device is cooler because that is actually available. Let me disable Copilot. So now I have I can write clojure code that basically is calling directly into Python. This is quite amazing. Torch tensor, and then you just make a clojure vector, for example. Now I check out the documentation. Oh, whoops, damn it. Cider doc. Yeah, I wanted to click this. That was hard to click. And I get the Python doc string, which is very useful, for example. So the integration is very advanced, very strong. I also have here the completions. Actually, I don't go to the file because if I visit the torch file in my emacs, if I visit the Python code, it just crashes my email. Like, it doesn't crash my emacs, but it's really bad. But I could go here. Can I go here? No. But I guess something like this? No. No definitions found. Huh. I think it works. For some things it works. Ah, here it worked. So it found the Python source. Yeah, that's the same thing that you have in a Python, like in a Python LSP or something. But we do this with, actually don't entirely know how it works, but we run the Python C bindings directly, and I think they, when you evaluate Python code, I think that each symbol like has some metadata, like the file and the line or something like that. So basically, you can introspect on Python objects, something along those lines. It's somehow in the C library for Python. It's part of it. You don't need LSP or something to do that. Like, the interpreter itself also keeps track of these kinds of metadata things. So if I say here foo pi, right, and that is a Python module where I say my value, and maybe I define a function called foo call, and that just returns, yeah, I don't know, maybe this or something. Now this is just, it's a better Python than Python, because if I develop Python, I would now either have this hot reload thing running, that's called py wait, Python hot reload, blah blah. I mean, you can set this up. True, yeah. It's kind of cute. has certain limitations, makes a file watcher, whatever. We don't need to, we just have a better Python, because we say require Python, and this is a namespace in Clojure now, and it's a function, and this runs Python code. I find this like this, and now let's say I have torch code here. I import torch as torch, I think, and now this returns torch as torch. Is this how torch works? Yeah, I think so. Torch. I already don't have a. Why actually this is? I have LSP mode running though. LSP mode. Doesn't it? Why does it not find this torch? No definition. No definitions found. Yeah, let's say that I return run normal, and that is 3x3 tensor. Yeah, so I just use Clojure to develop it. Yeah, like this. Okay. Yeah. So now, wait, one sec. Require Python 100. Yeah. Okay. So this is still the old one, because they have something special to reload or something like that. Force reload. That is flag this no arg list. Reload. Reload. Okay. You pass another keybind code. Key argument. Okay, and now it updates. Okay, so I can literally do this, and just call my my updated function. So if I can develop Python, yeah, it's a more powerful Python development than Python, and it prints really nicely as well. Also, it's also really good at NumPy. Yeah, if I say something like this, it's a huge tensor, and it prints like this is just beautiful. I think this. Yeah, I think this is how NumPy also prints. I'm not entirely sure, but this is very manageable. If you accidentally print a tensor, or you actually have like a flow where like you can actually print tensors, and sometimes it's actually kind of useful. Like, I mean, this naja, either way. So that is already is like, I think already with this is like, I rather develop Python like this than with the Python tools that the Python ecosystem gives me. Just this I find, but yeah, it's the power of Clojure. So now I want to run torch HD, and I thought I'm gonna use their example. There is, yeah. Okay, these are these handwritten digits. Okay, so there's one row with 0, I suppose, one with ones, and so forth. Okay, yeah. And these are 28 by 28 pixel images from NIST. Yeah, cool. So I want to follow them basically solving this classification problem, I suppose you can call this. Yeah, because we want to classify. If we see one of these and we don't know what it is, we want to say it's 0, and so forth. So I want to build a classifier, and I want to do this with the Torch hyperdimensional computing library they have here. So there's not much code. Yeah, it will be an example of a Python class as well. Yeah. This is a Torch. Yeah, this is the Torch neural network library. Okay. Man, the funny thing is, I mean, in a way, this is the hello world. This is also kind of the hello world. Does this load? Probably not, because no module need torch metrics. Okay, let's install some modules, and this is the second thing. So after I activated my environment, I say pip install, and then I install something. and it's the same thing. I don't restart anything because it's just Python sources that it needs to load. And now it just has more Python sources. Okay, now I'm waiting. Oh, 11%. It's printing out something already. Cool. I guess it downloaded the data using CUDA device. That's beautiful. And Java. Oh yeah, 200 MB. That's not much for the moment. Okay, now the CPU is doing something. Oh yeah, training. It's training. It only needs 200 MB to do that. And then I'm guessing it's doing something multi-threaded. This is the Java process that uses one CPU. No, it uses one CPU, yes. Yeah. Testing, alright. Training. Oh, it's training again, second time. Okay. Okay, so what embeddings, random, size, out features. Aha. Okay, I guess this is a function that actually I can play around with it. Yeah. One sec, I can just play around with it. Okay, so I can require torch nn as nn. Oh, this takes really long. Okay, and then I say, for example, something like this. Just do this embeddings. I was like embedding. That came from torch HD embeddings. All right. From torch HD, one sec. I need to do this. I think. What? Wrong. Okay. Embeddings, random. Does this work like that? No, wait, one sec. Embeddings is a namespace, and then random. Yeah, like this. Okay, 28. Yeah, whatever, 28 times 28 out features. Out features is out features encoder dimensions. Yeah, sure, makes sense. Yeah. So this position embedding gives me a random output hypervector with this input size. So I'm guessing that for each pixel I get hypervector. If the pixels like so that I can mark the position of a pixel basically. So this is a position embedding, a random one. Okay, let's try. So this is the I call this dimensions, and then that is 10,000. And that's some error. That was 28 times 28. So it's the full grid or something. And now I guess this is they use it here, right? Position weight. Okay. So I say pi and then weight. That is this is also a parameter. This is cool. So we really go like neurosymbolic because so this goes into the torch way of doing neuronal nets where like torch, I know that parameters are basically, it's just matrices that, or tensors or whatever, that torch is able to keep track of for machine learning purposes. So I'm guessing for backprop gradient descent kind of algorithms or whatever. So this basically integrates with this, so it's kind of cute, I guess. So this is a random. What does that do? Can I do this? Torch D and then level. What is that? What is it? Wait, this torch level. Okay. Tell me about this. I want to know what this is. Yeah. Okay. This is another map multiply permute tensor. But I'm gonna call those hypervectors from now on. Okay. So and then what? It's so good that it prints nice. Okay. It's just 10. It's just 10. I mean, I can do. So yeah. Now you do this. And you just say Python PyTorch API, right? You can also you can say Python class, Python type, yeah, and that is a tensor, MAP tensor, actually, MAP tensor, cool. If I go into the repo, I will also, does this print like that? No, does this? I guess the class is actually called MAP tensor, that's what I guess. Okay, so I'm guessing we translate that into a nice keyword, I suppose. Yeah, pretty sure this is what this thing is doing. Python type, get Python type. Yeah, get Python type. Oh, I don't have a project wide search inside here. I would need to. I don't run into this because I clone everything. Yeah. But yeah, here's some emacs usage with Qt browser. I actually do this without going to the mouse, right? And then I go here, I make a shell, I say git clone, I just type this. I think my Git has a key binding for this, but I mean, yeah, just use your computer, like libpython-clj. And when I search here for get Python type, then there are some implementations. Here, type key value, PyObject type key value. This is the one that makes something a keyword as well. Somewhere, I think. If non-type. Py string PyObject. Compute if absent type address type name key value. This is some cache. Here, kebab case keyword. CSK. What's that? Camel snake kebab core. This is a clojure library. Funny. Okay, this was just a tangent into understanding what I do at my understanding what my program is doing. It's these kinds of things I sometimes like getting an understanding of what is happening. Funny. Camel snake kebab. Yeah, it takes camel snake and makes kebab out of it. Okay, and this is actually used in the low level of libpython-clj here in the Python foreign object. What is that? FFI, foreign function interface. Foreign function interface. Give me a type keyword, and that one takes a Python type name and makes this out of it. If it is. Yeah, I think it's good to know. So this camel case, and yeah, that is. Oh wait, kebab case. Oops, where am I? Kebab case keyword. Ah, there you go. So this is how this is the same. This is how this is the same. Okay, and it prints cool. Also, yeah, I think that this is kind of yeah. I mean, you could have left it with this string, but yeah, I'm not sure what the trade-offs were. No, I'm fine with this. Okay, oops, delete. Yes. Okay. Let's continue with typing what they have in there getting started. Yeah. Okay, so I want to know what this is, what the weights are. Ah, there's something like that. You make some mapping between something and then why 10? What is 10? 3 times 3. What the fuck? What are 10? I'm not sure. Weight. This is just a weight. Ah. But why 10? To have like a little bit of a spread out or something like that. No, okay, let's see. Okay, seasons. You have 4 seasons. Ah, yeah. I see. You have more seasons than there are that happen. Circular. Ah, uh-huh. Okay. I see. So so this one is completely random. So they're basically seed vectors. So they're all different. And these ones, they probably like yeah, okay, so if I take like the first one of these and compare it to the second one, then it's probably more similar than if I compare the first with the last or something. So that they are all more similar. They're more similar kind of in a level, I guess, like something like this, like A, B, C, D, or something like that. And I'm guessing that this is how this works, that A and B are more similar, and then D and A are not similar. So if I, so how operations, because how do I check the similarity between two? I'm gonna check in their repo. Just gonna go into a repo. I'm gonna, yeah, this one, for example, it must implement a similarity. Dot similarity, for example, will work, I think. Yeah, okay, yeah, it's not closure, I guess. Okay, what doesn't work? Env is not supported. Ah, yeah, okay. I was wondering if that is supported or not. Tensors, or, yeah, like this. A is, this supported, I think. We can also put it into a list. I think that should be supported because it there's a conversion to Python generator or something, so that's why it's able to do this. Yeah, since I only have 10 items, this is not a problem. Okay, so that, yeah, okay, you get a number like this. You probably need to, I'm not entirely sure why they, yeah, I guess they will say how they do that, why they do that. D would, so this was, what was that? This returns a tensor, yeah, okay. I guess that's for PyTorch. You call a function called item. Yeah, that's now a Python. This is a Python pyget type, Python type, Python float, just as float. Python type. If I say something like this, that's just an error. No, that actually also makes it a Python value, I suppose. Py as Python. I guess that's the same. Yeah. So yeah, all data is zero copied between the JVM and Python. If I say item, yeah, item. That's of course that's easy because that's just a 32 bit float. But yeah, this also works for NumPy. Yeah, this one I think this should basically be zero copied. So if I say NumPy array, but yeah, there's documentation for this. I think maybe there was something you needed to do for this. No, I forget right now. It's good to check the documentation on this part. But yeah, basically it's available that you have zero copy between all the things, which is like also D-type. So this is quite nice. So if I divide this by the dimensions, I get something like 0.8. Yeah, if I have 100 levels, right? Then I'm guessing now that the similarity is way closer, like 99, like 90 blah 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 or something, and there's probably some logic now that would say 99. Yeah, this is what makes sense because then these first twos are like closer to each other, and sort of as an invariance. If I take the if I take like count access divided by 2 and then floor and then yeah, then this should roughly be the similarity between A and this one x should roughly be half. Yeah, and it should always roughly be half, I suppose. Like also if I have 10 here. Yeah, I guess this is roughly the case. And yeah, if I have, but now I'm not sure if I will start making things slow. But if I have 1,000, yeah, still fast. This is kind of cool. Yeah, and now one other thing would be that so A and B, and then A and X some again directly in the middle, and then X and the last one. There should also be a half. Yeah, yeah, and A and the last one. This should yeah, it should be 0. It should be 0. Yeah, this makes sense. And so this is actually interesting. Making two hypervectors that have 0 similarity is actually kind of like the you need some kind of clever math to make this, because two random hypervectors will always be roughly random pi a torch, sum. I need to think for a sec. Dimension. How does this work again? I pass dimension. I say sum in the first dimension. Ah, yeah, genau. Do I do this correct? Wait one sec. Let me quickly double check that I do what I think I do. Torch. Tensor. Say -1, -1, -1, and 1, 1. Okay, so this is how you basically you develop something like Torch or whatever other Python library you look at the Repl with libpython-clj, right? So you do the same. It's just repetitive. It's just normal having the Repl. So yeah, I see that if I sum dimension 1, this is this is what I wanted. I wanted to check if here I would get something like minus 2 10 minus 20,000 and 20,000, because that would be this hypothesis here that it goes from -1 to all ones or something. But I don't think it's doing that. No, it's more sophisticated. It's doing something else. I'm guessing that maybe it makes a random seed for the level. Man, this is cool. Levels per span, threshold, span start, special case. Block size. Ah, cool. Okay, they also do this for block sparse vectors. Okay, cool. I'm excited about this. Okay, these hypotheses were not correct. It's doing something else. Yeah, and then I mean, yeah, sure. Now you develop your torch code the same way, and of course you make little example inputs, and then you see it working, or you see what it does. You just check what it does. Okay, and then circular is the same thing roughly. But A is now also similar to D, so it's kind of cool. I'm already excited using using this library. Seasons, okay, var. Was var ist, was ist var? Achso, R, this is their record. Okay, so I'm gonna just call them symbol HDs or something, or vars, HD vars. Okay, that's 3 random hypervectors. Okay. Okay, 3 through types, 10 weight levels. Ah, okay, that's why level. Okay, just think in terms of I want levels and for seasons and 3 variables. The figure below illustrates the distance between the pairs of hypervectors in each set. Ah, cool. Random. What? IJ. I have 9 random hypervectors, so they 9. So 9 and 9 are similar, and everything else is blue. Everything else is roughly half distance. For the level, everything that I of course I have this diagonal every time because I look at myself. I always have one similarity for myself, so red, and then 9 and 0 are not similar, and but this is cute. The similarity kind of goes and circular, so that if I'm sort of close at the end, then I'm similar again to myself. Beautiful. Yeah, you see that there's only one red tile or orange tile on the corners here because there's only 2 places where the circle meets, kind of like funny. Require Python. Yeah, I'm gonna call them HD embeddings. I think this works like that. Yeah, now you can say HD embeddings, embeddings level. So this also has a level function. Oh, this returns a class. Oh, this is a class. 10d 0 to 100. Yeah, okay, it doesn't work. I guess you do need the keywords. I think that works like that. Yeah, okay. Returns a level 10 with 10 things. Achso, and now I can. Achso, this is a function now. Oh, okay. Oops. This thing is a function because. Yeah, why not make random things function, I suppose. Okay, yeah, I get a tensor out of this. What happens if I have something too large? Okay, I'm guessing I get the large one, the largest one. My level weights. Embedding. Okay. Okay, so that one with say that the input is 1000, and then actually equal will work, I think. No, equal says so Boolean tensors. Okay. Yeah. Okay, I need to this all close. Yeah, that's basically this, you only you have this function because you have floating points in torch. So this is close means really close. So this is false, of course, and 200 that should be okay. Also true. Well, yeah, okay. I mean, I can tell you that some abstraction like this is for sure like seems useful. At least, I mean, I want to be able to say that. I'm not sure that I needed to have a thing that is a function that I can call it as a function. I'm not sure if this was important to me, but yeah, okay.